Hi students, welcome today online class. Okay, today we will discuss a theorem statement, that is, if s which is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent a pair of straight lines if and only if the condition such as delta which is equal to abc plus 2fgh minus af square minus bg square minus ch square is equal to 0. And then the next condition is the value of h square must be greater than or equal to ab, and the value of g square must be greater than or equal to ac, and the value of f square must be greater than or equal to bc. Okay, so these are the necessary and sufficient conditions for the equation s is equal to 0 represent a pair of straight lines. Okay, now if s is equal to 0 represent a pair of straight lines, then the angle between the pair of lines is same as the angle between pair of lines represented by the equation s is equal to 0. Here, if s is equal to 0 represent a pair of straight lines, then angle between the pair of lines is same as the angle between the pair of lines represented by the equation s is equal to 0, which is given by theta is equal cos inverse of modulus of a plus b divided by under root of a minus b whole square plus 4h square. And similarly we get the formula to find theta in terms of tan, that is tan inverse of 2 times of under root of h square minus ab divided by modulus of a plus b, okay, which is equal to theta. Okay, next, here the lines represented by the equation s is equal to 0 are parallel if h square is equal to ab. Okay, if h square is equal to ab, then the lines represented by the equation which is s is equal to 0 are parallel. Okay, so this is the condition for the lines represented by the equation s is equal to 0 are parallel. And next condition, next perpendicular condition, that is a plus b is equal to 0. So this is the condition for the lines represented by the equation s is equal to 0 are perpendicular. Next, let us discuss one more theorem, that is, if s which is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represent a pair of parallel lines, then the condition would be h square is equal to ab. That means the value of h square must be equal to the value of ab. Similarly, second one, the value of af square must be equal to the value of bg square. And next, let us discuss the distance between these parallel lines, which is given by a formula 2 times of under root of g square minus ac by a into a plus b. Okay, we can also use this formula, that is 2 times of under root of f square minus bc divided by b into a plus b. Okay, so this is the formula for finding distance between two parallel lines which is represented by the equation s is equal to 0. Now let us see proof of this theorem. Okay, now proof. If s is equal to 0 represent the lines which are Lx plus My plus N1 is equal to 0 and Lx plus My plus N2 is equal to 0. Let us name this as equation 1 and this equation has 2. Students, if you observe that here equation 1 and 2 are parallel lines. 1 and 2 are parallel lines. Okay, suppose S is equal to 0 represent these two parallel lines, then S can be written as product of these two lines, that is 1 and 2. Therefore, S which is equal to Lx plus My plus N1 into Lx plus My plus N2. Okay, so now let us multiply these two equations in right hand side. Okay, so now which is equal to L square x square plus Lx into My Lm xy plus L N2 x plus Lm xy plus m square y square plus m N2 y plus L N1 x plus m N1 y plus N1 N2. So now which is equal, this equation can be written as L square x square plus, by taking xy as a common factor, so here we get Lm plus Lm into xy. Next m square y square plus, next let us take xy x is a common factor, we get L N2 plus L N1 into x plus, next let us take y as a common factor, we get M N2 plus M N1 into y plus N1 N2. Now let us compare coefficients on both sides. Okay, let us compare coefficients on both sides. So here we get the values. A has L square. What is A? L square. What is B? M square. Okay, C has N1 N2 and 2H has Lm plus Lm, 2Lm. Okay, next 2G has L N1 plus L N2. Okay, 2F has M N1 plus M N2. Okay, first let us find H square. H square is nothing but Lm whole square, which is equal to L square M square, and AB is nothing but L square M square. Okay, therefore H square is equal to AB. Okay, next condition. So for proving next condition, that is AF square minus BG square, so here just we have to take 2G by 2F. Okay, so which is equal to 2G is nothing but L of N1 plus N2 divided by 2F is nothing but M of N1 plus N2. Okay, so which is equal to L by M. Okay, so here 2 get cancelled. Okay, so from this we get G by F is equal to L by M. G by F is equal to L by M. So here 2 get cancelled and N1 plus N2 also get cancelled. So finally we get G by F is equal to L by M. G by F is equal to L by M is nothing but G square divided by f square is equal to L square divided by m square. Okay, but L square is nothing but A divided by m square is nothing but B. Therefore, G square by f square is equal to A by B. So from this we get A f square is equal to B G square. So next let us find distance. Let us prove that distance between two parallel lines. Okay, third one. Okay, already we know that the formula for distance between two parallel lines. Okay, the distance between BTN between two parallel lines is given by formula, that is modulus of n1 minus n2 divided by under root of L square plus m square, L square plus m square. Okay, so now which is equal here n1 minus n2, modulus of n1 minus n2 can be written as under root of n1 minus n2 whole square divided by under root of L square is nothing but A plus m square is nothing but B. So now which is equal to under root of here n1 minus n2 whole square can be written as n1 plus n2 whole square minus 4 n1 n2 divided by under root of A plus B. So now which is equal to n1 plus n2 is nothing but 2g by L, because 2g is equal to L n1 plus L n2. n1 plus n2 is nothing but 2g by L whole square minus 4 n1 n2 is nothing but C divided by A plus B under root of. Okay, so here what is LCM? L square is LCM. Okay, so here under root of 2g by L whole square minus 4c A plus B can be written as 4g square minus 4 L square C divided by A plus B, 4 into A plus B under root of. Okay, so here by taking 4 as a common factor in numerator, so here we get 4 of g square minus L square is nothing but A C divided by 4 times of A plus B. Okay, so here what is LCM? L square is LCM. Okay, so here under root of 2g by L whole square minus 4c divided by A plus B can be written as 4g square minus 4L square C divided by 4 into A plus B into L square. Okay, L square is nothing but A. Okay, here by taking 4 as a common factor in numerator we get 4 times of g square minus AC. A is nothing but L square divided by 4 into A plus B. L square is nothing but A. So here 4 get cancelled. So finally we get g square minus 8c, g square minus AC divided by A into A plus B under root of. Similarly, we can prove that distance between two parallel lines is given by the formula is 2 times of under root of f square minus bc by b into A plus B. Next, let us see the point of intersection of pair of lines represented by the equation s is equal to 0. So here the formula for point of intersection of the lines represented by the equation s is equal to 0 is given by hf minus bg divided by ab minus h square, comma gh minus af divided by ab minus h square. Okay, so this is the formula for finding point of intersection of the pair of lines represented by the equation s is equal to 0. hf minus bg by ab minus h square and gh minus af by ab minus h square. Next, let us discuss some solved problems. Okay, first one, show that the equation which is 2x square minus 13xy minus 7y square plus x plus 23y minus 6 is equal to 0 represent a pair of straight lines. Okay, and also find angle between them and also find point of intersection of the lines represented by the equation s is equal to 0. Okay. First, let us consider the given equation has s. Okay, s which is equal to 2x square minus 13xy minus 7y square plus x plus 23y minus 6 is equal to 0. Okay, so then by comparing the given equation with the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, we get the values a has 2, 2h is equal to minus 13, therefore h is equal to minus 13 by 2, b has minus 7, next 2g is equal to 1, therefore g is equal to 1 by 2. Okay, next 2fy, f is equal to 23 by 2. Okay, and c is equal to minus 6. Okay, so now we have to show that the given equation, that is s is equal to 0, represent a pair of straight lines. Okay, so now to show that the given equation s is equal to 0 represent a pair of lines, just we have to show that the condition abc plus 2fgh minus ef square minus bg square minus ch square is equal to 0, and also find the condition, that is h square must be greater than or equal to ab and f square must be greater than or equal to bc and g square must be greater than or equal to ac. Okay, if at least one condition is not satisfied, then we can say that the given equation, that is h is equal to 0, cannot represent a pair of straight lines. First, we have to find the condition 1, that is abc plus 2fgh minus af square minus bg square minus ch square. So now, which is equal, abc is nothing but a is nothing but 2, b is nothing but minus 7, c is nothing but minus 6. That means substitute all these values here. We get 2 into minus 7 into minus 6 plus 2 into 23 by 2, g is nothing but 1 by 2 minus 13 by 2 minus 2, f square is nothing but 23 by 2 whole square minus 7 1 by 2 whole square plus 6 into minus 13 by 2 whole square. Okay, so just we have to simplify this equation. Okay, 2 into minus 7 into minus 6 is nothing but 84. Okay, so here 2 get cancelled. Okay, and 2 into minus 13, 2 into 2 get cancelled, 23 into minus 13 is nothing but minus 299, and 2 into 2 is nothing but 4 minus, okay, by simplifying 2 into 23 by 2 whole square, so here we get 1058 by 4. Okay, next plus 7 by 4 plus 6 into minus 13 by 2 whole square is nothing but 1014 divided by 4. Okay, so now which is equal to 84. Okay, plus, okay, so here by simplifying minus 299 by 4 minus 1058 by 4 plus 7 by 4 plus 1014 by 4, we get 1021 minus 1357 divided by 4. Okay, so now which is equal to 84 minus 1021 minus 1357 is nothing but 84. Okay, 1021 minus 1357 by 4 is nothing but 84. So finally we get 0. Okay, therefore first condition is satisfied. Next, let us see second condition, which is h square greater than or equal to ab. Okay, so first we have to find h square. H square is nothing but 169 by 4. Okay, next AB. AB is nothing but minus 14. Okay, so here h square is nothing but 169 by 4. This is positive. AB is nothing but minus 14. This is negative. Therefore, h square must be greater than AB. Okay, similarly, we have to find f square. F square is nothing but 529 by 4. BC is nothing but 42. Okay, therefore f square greater than or equal greater than BC. Similarly, G square is nothing but 1 by 4. AC is nothing but minus 12. Therefore, G square greater than AC. Therefore, the given lines represent a pair of straight lines because the condition 1 and true. Next, we have to find angle between the pair of lines represented by the equation s is equal to 0. Okay, already we know that formula for angle between the lines represented by the equation s is equal to 0 is given by cos theta is equal to modulus of a plus b divided by under root of a minus b whole square plus 4h square. So which is equal to 2 minus 7 divided by under root of 2 plus 7 whole square plus minus 13 whole square. Okay, 2h is nothing but minus 13. Okay, so now which is equal to 5 by 2 plus 7 9 square is nothing but 81 plus 13 square is nothing but 169 under root of. Okay, 5 by 81 plus 169 is nothing but 225. Okay, so now which is equal 5 by 225 can be written as root of 225 can be written as 5 root 10. Therefore 1 by root 10. Therefore theta is equal to cos inverse of 1 by root 10. Next, we have to find the point of intersection of the lines represented by the equation s is equal to 0. Already we know that formula for finding point of intersection of the lines represented by the equation s is equal to 0 is given by point of intersection. Okay, HF minus BG by AB minus H square comma GH minus AF divided by AB minus H square. So now which is equal to H is nothing but minus 13, F is nothing but 23 by 2 minus BG is nothing but 7 by 2. Okay, divided by AB is nothing but minus 14, H square is nothing but 169 by 4. Okay, next GH is nothing but minus 13 by 4 minus AF is nothing but minus 23 divided by minus 14 169 by 4. Okay, so now by simplifying this term and this term we get 19 by 15 comma 7 by 15. Okay, so this is the point of intersection of the lines represented by the equation s is equal to 0. Next, let us see second problem. Okay, find the value of lambda for which the equation lambda x square minus 10xy plus 12y square plus 5x minus 16y minus 3 is equal to 0 represent a pair of straight lines. Okay, so now we want to find the value of lambda for which the equation s is equal to 0 represent a pair of straight lines. Okay, first let us consider the given equation as s. Okay, s is nothing but lambda x square minus 10xy plus 12y square plus 5x minus 16y minus 3 is equal to 0. Okay, suppose the equation s is equal to 0. So this is the equation s is equal to 0. Okay, so next we have to compare the given equation with the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. We get the values a has lambda, okay, h has minus 5, b has 12, g has 5 by 2, f has minus 8, c has minus 3. Okay, already we know that the condition for the equation s is equal to 0 represent a pair of straight lines. Okay, now the condition for which the equation s is equal to 0 represent a pair of straight lines is given by a b c plus 2fgh minus a f square minus bg square minus ch square is equal to 0. Now let us substitute all values here. Okay, that means a b c f g h. So here we get, okay, a b c is nothing but minus 36 lambda, 2fgh, 2 f is nothing but minus 8, g is nothing but 5 by 2, h is nothing but minus 5 minus a is nothing but lambda, f square is nothing but 64 minus 12, g square is nothing but 25 by 4, c is nothing but minus 3, that means plus 3, h square is nothing but 25 is equal to 0. Okay, by simplifying this equation we get minus 36 lambda plus 200 minus 64 lambda minus 75 plus 75 is equal to 0. Here plus 75 minus 75 get cancelled. So finally we get minus 36 lambda minus 64 lambda minus 100 lambda plus 200 is equal to 0. Therefore 100 lambda is equal to 100. Therefore lambda is equal to 2. Okay, therefore lambda is equal to 2. So we can say that a is also 2 because lambda is equal to a. Okay, so now let us check other conditions which are h square greater than or equal to ab. Okay, g square greater than or equal to ac, f square greater than or equal to bc. Okay, now h square is nothing but 25, ab is nothing but 24. Therefore h square greater than ab. Okay, next g square is nothing but 20 by 4, ac is nothing but 6, 20 by 4 is nothing but 6 point something. Okay, therefore g square greater than ac. Next f square is nothing but 64, bc is nothing but 36. Therefore f square greater than bc. Okay, therefore the given equation represent a pair of straight lines if lambda is equal to 2. Next, let us see third problem. Show that the pair of straight lines which is 6x square minus 5xy minus 6y square is equal to 0 and 6x square minus 5xy minus 6y square plus x plus 5y minus 1 is equal to 0 form a square. Okay, so first, okay, now let us see how to show that these pair of straight lines form a square. Okay, so first let us consider the equation h which is equal to 6x square minus 5xy minus 6y square is equal to 0. If you observe that, students, this is the homogeneous equation. Okay, now also consider the equation s which is equal to 6x square minus 5xy minus 6y square plus x plus 5y minus 1 is equal to 0. Okay, so this is non-homogeneous second degree equation. Okay, now let us see how to show that this pair of straight lines forms a square. Okay, first we have to find pair of straight lines represented by the equation h is equal to 0 and pair of straight lines represented by the equation s is equal to 0. Okay, so here h can be written as 6x square minus 9xy plus 4xy. Minus 9xy plus 4xy is nothing but minus 5xy minus 6y square. So now which is equal, so here by taking 3x as a common factor from first term and second term, we get 3x of 2x minus 3y plus, next let us take 2y as a common factor from third term and fourth term. Here we get 2x minus 3y. Okay, therefore this equation is nothing but 2x minus 3y, okay, into 3x plus 2y. Okay, therefore 3x plus 2y is equal to 0 and 2x minus 3y is equal to 0 represent a pair of straight lines represented by the equation h is equal to 0. Okay, therefore 3x plus 2y is equal to 0 and 2x minus 3y is equal to 0 represent a pair of straight lines represented by the equation h is equal to 0. Let us name this as equation 1 and this equation has 2. Next we have to find pair of lines represented by the equation s is equal to 0. Okay, so here for finding pair of lines represented by the equation s is equal to 0, just we have to consider the equation s is equal to 0 represent two lines which are 3x plus 2y plus c1 is equal to 0 and 2x minus 3y plus c2 is equal to 0. So just we have to consider the equation s is equal to 0 represent two lines which are 3x plus 2y is equal to 0 and 2x minus 3y plus c2 is equal to 0, because 3x plus 2y and 2x minus 3y represent a pair of lines represented by the equation 6x square minus 9xy 6x square minus 5xy minus 6y square. Okay, so let us consider s is equal to 0 represent two pair of lines which are 3x plus 2y is equal to 0 and 3x plus 2y plus c1 is equal to 0 and 2x minus 3y plus c2 is equal to 0, because 6x square minus 5xy minus 6y square, 6x square minus 5xy minus 6y square represent two lines which are 3x plus 2y and 2x minus 3y. Okay, so here s which is equal to 6x square minus 5xy minus 6y square plus x plus 5y minus 1 can be written as product of these two lines. That means 3x plus 2y plus c1 into 2x minus 3y plus c2. So now we want to find c1 and c2 values by comparing these two equations. Okay, so just we have to consider the equation s is equal to 0 represent two lines which are 3x plus 2y plus c1, 2x minus 3y plus c2, because 3x plus 2y, 2x minus 3y represent a pair of lines represented by the equation 6x square minus 5xy minus 6y square. Therefore s which is equal to 6x square minus 5xy minus 6y square plus x plus 5y minus 1 which is equal, let us multiply these two equations. So here we get 3x into 2x, 6x square, next minus 9xy plus 3c2x plus 4xy minus 6y square plus 2c2y plus 2c1x minus 3c1y plus c1 c2. Now let us, okay, so now which is equal 6x square minus 9xy plus 4xy is nothing but minus 5y square minus 6y square plus, next let us take x as a common factor. We get 3c2 plus 2c1 of x plus, next let us take y as a common factor. We get 2c2 minus 3c1 of y plus c1 c2. Now let us compare coefficients on both sides. So here we get 3c2 plus 2c1 is equal to 1 and 2c2 minus 3c1 is equal to 5. Okay. So now by solving these two equations we get c1 and c2 values. Okay. So by solving these two equations we get the values c1 has minus 1, c2 has 1. Therefore the equation s is equal to 0 represent two pair of straight lines which are 3x plus 2y. c1 is nothing but minus 1 and 2x minus 3y plus c2 is nothing but plus 1. Therefore s is equal to 0 represent two pair of lines which are 3x plus 2y minus 1 is equal to 0 and 2x minus 3y plus 1 is equal to 0. Let us name this as equation 3 and this equation has 4. Okay. So now we want to show that these four lines are, that means line 1, that means equation 1, equation 2, equation 3, equation 4 forms a square. So now we want to show that these four lines form a square. Clearly, if you observe that equation 1 and equation 3 are parallel. Equation 1 and equation 3 are parallel, and also equation 2 and equation 4 are parallel. Okay, so this is square. Okay, this is equation 1, this is equation 2, this is equation 3, equation 4. 1 and 3 are parallel and 2 and 4 are parallel. Okay, already we know this is origin O. Okay, so this is A, this is B, this is C. Okay, origin, because this is homogeneous equation. Okay, clearly 1 and 4, 1 and 2 and 2 and 3, 3 and 4 are perpendicular because slopes of these lines. Okay, that means product of slopes of these lines is minus 1. That means product of slopes of the line 1 and the line 2 is minus 1. Similarly, the product of slopes of the line 2 and the line 3 are minus 1, and the product of slopes of the line 3 and the line 4 is minus 1. So therefore 1 and 4 and 1 and 2 and 2 and 3 and 3 and 4 are perpendicular. Okay, so next we have to show that the distance from the origin to the straight line origin to the straight line 4 is same as the perpendicular distance from the origin to straight line 3 is same. Suppose if we show that the perpendicular distance from the point origin to the straight line 4 is same as perpendicular distance from the origin to straight line 3, then we can say that the given lines forms a square. Okay, that means suppose if you show that OA is equal to OC, then we can say that the given lines forms a square. OA is nothing but perpendicular distance from the origin to the straight line 3. OC is nothing but perpendicular distance from the origin to the straight line 4. Okay, OC or OA. OA is nothing but perpendicular distance from origin to straight line 3. Tell me perpendicular distance from the origin to straight line. 1 by under root of 2 square plus minus 3 square is nothing but 1 by root 13. Similarly, OC is nothing but perpendicular distance from origin to straight line 4 is nothing but 1 by under root of 2 square 3 square plus 2 square is nothing but 1 by under root of 13. Therefore OA is equal to OC. Okay, Therefore, the given lines forms a square because 1 and 2, 1 and 4, 2 and 3, 3 and 4 are perpendicular, and also 1 and 3 and 2 and 4 are parallel, and also perpendicular distance from the origin to straight line AB is same as perpendicular distance from the origin to straight line BC. So we can conclude that the given straight lines forms a square.